So our goal for today is to use linear programming to find max and min values. What linear programming is, it's the same thing that we were doing in 3.3, except for now we're going to be doing it with more linear inequalities. So there won't just be 2 on there. There might be 3, there might be 4 linear inequalities. And when you go to graph them, so the problem comes from graphing a system of inequalities, just like we were doing in 3.3. When you go to actually graph these, sometimes the feasible region, so the region that is your solution that you color in, it's bounded. Okay, so it's bounded if it's completely enclosed, whereas here, this feasible region is unbounded by constraints because it continues forever in these directions. Do you see that? So we could continue on this graph. If we had more space, this line would continue going up. This line would continue going down in this direction, and we could continue to color in more of that region. It's not bounded. So if you zoom out, there's more to shade. Do you see the difference? Whereas if you zoom this one out, it's just that shaded region looks like it gets smaller because you're looking at more blank white graph. Okay. So we're going to do just one example together. You'll notice that the back side of these notes are blank. There's nothing there. We just have one example that we're going to do, and then you guys can get started on your assignment, and then that's what you'll finish for your Friday assignment, is to finish this assignment. So let's look at these problems. The first thing that we're going to do is we're going to graph this system of inequalities, and in order to do that, we want to make sure that we put some scales here on this graph. So let's go up by halves because this is a pretty large graph, and I'm pretty sure we'll have plenty of room. Sometimes it's a little bit easier when you make your scales go up by a half because you see more of your graph that way. It's zoomed into like a specific part. So it just went up by halves. I labeled every one. So half, 1, 1.5, 2. And then what we're going to do is we are going to graph the system. So the first thing that we are going to graph is y is greater than or equal to 2. How do I graph y equals 2? What does that line look like? It's a horizontal line. So you go to your y-axis, you find 2, put a point, and now we're just going to draw a horizontal line through that because the slope is 0. Okay. Now you'll notice when we're doing linear programming, all of them are greater than or equal to or less than or equal to. It's always going to be or equal to. You'll always have solid lines on these ones. So let's figure out here. Are we going to be shading up or down? Y is greater than or equal to 2. Y is greater going up. Yep, so I'm going to put the arrows on here. And this is why I was saying that sometimes teachers will teach you to draw with 2 colors when we're solving systems. And then where the colors overlap, that's your solution. But the important part here is a lot of times we're going to have more than 2. And if you get 3, 4, 5 colors on a graph, that's going to get pretty confusing. So the arrows are really going to help you. And if we need more Post-it notes, I'll give you guys more Post-it notes too. All right. How about this? X is greater than or equal to 3. How am I going to go about graphing that one? That's a vertical line through X, so go through the X-axis. Find that 3, and this one's that vertical line. So again, we're going to do another solid line here because it's or equal to. Now this is the only one that we look to left or right. So if we put our pen on x here, it says x is greater than or equal to 3. So is it greater to the left or is it greater to the right? To the right. The right numbers are larger, so we're going to be shading this one to the right. All right, now we're down to the last one. Y equals negative x plus 8. How would I go about graphing this one? I go to my y-axis. My y-intercept is at 8, so I'm going to put a point on 8. My slope is negative 1, so I'm going to go to the down 1, right 1. So I'm going to go down to 7, right to 1. Down to 6, right to 2. Down to 5, right to 3. And I'm going to keep going until I run off my graph. Then I can connect these with a solid line because it's or equal to. And now I'm going to have to look at y is less than or equal to. So where do I shade in comparison on my y-axis here? Am I going to shade up or am I going to shade down? Where is y less than my pen right now? Down towards 7, 6, 5, 4. So on this line, we're shading down. So far, so good. All right, so then here's where your Post-its come in handy. So we're not shading on this side of the green. We're not shading on this side of the blue. And we're not shading on this side of the red. And that's why we draw those arrows on there so that we can see where that feasible region is. And we can see that it's this nice triangle right here. And I will come around and give you guys more Post-it notes because I know I only handed out 2 the other day. So, one of the most important things with this problem, because there's so much going on in this graph, you want to make sure, and I see this happen every year in Algebra 2, regular Algebra 2, and in 2A, you want to make sure that you have scales on your graph. Because a lot of times what happens is people lose their axes. So what I see happen is people don't put the scales on here, and then they get confused and they think that this blue line is all of a sudden now their x-axis, or the red line is now their y-axis, and they get confused as to where numbers are at. And it's really important that we aren't getting them mixed up, because our next step is we have to know the difference between what the constraints are and the vertices. Constraints are going to be the lines that border the feasible region. Did everybody get a Post-it? Okay. Okay, so those are your constraints. Those are the lines or the edges. Okay. The vertices or the vertex are your corners. Those are where your edges meet or your constraints meet. So let's use green here. You have these points. So this would be a point. That's a point. That's a point. That's a point. It's the corners of your constraints. So in this one, there's only one because these go on forever. And that's another mistake that people have, and is they just go to the edge of their graph and they say that those are extra constraints. They're not. It's just where extra vertices. They're not. It's where the constraints meet. Those keep going on forever and ever. So those constraints, we can't even see them all because they keep going in those directions. Does that make sense? So looking back at our graph then, we have 3 constraints. And then we have we have 3 vertices. 1, 2, 3, because it forms this triangle. So to name these vertices, you have to name where this point is located. So looking at this point right here, what's the location of that point? That's why it's important our scales are on our graph, and we're used to putting those scales on every time. So we can look and say, okay, the x of that point is 3. The y of that point is 2. So one of these vertices is at 3, 2. The next vertice, this one here, doesn't matter the order you name them in, that has an x value of 6 and a y value of 2, so 6, 2. So we're naming these vertices. This one here, this last vertice, that has an x of 3, so 3, comma, the y-axis, it's at 5, so 3, 5 is where that vertice is. Once you have your vertices, it says to find the maximum value for the function, okay? A company would use this in order to find out how to maximize their profit. The P is a profit, okay? If you have a C equation, that's your cost. So companies want to minimize their cost and maximize their profit. And this allows them to do that, okay? So if it's profit, that's how much money you're making on something, we want to maximize it. So what we're going to do is we're going to figure out the profit if you plug in 3, 2. 4 times the x value is 3 minus 2 times the y value is 2. Now just use your calculator. What is the profit going to be? 4 times the 3 minus 2 times the 2. 8. Your profit is 8. That's one of our options. Okay? Then we're going to try another one. Let's figure out the profit with the vertice at 6, 2. 4 times the x value is 6 minus 2 times the y value is 2. Plug it in your calculator. 4 times 6 minus 2 times 2. We're going to have a profit of 20 this time. We still have one left to check, the 3, 5. So 4 times x is 3 minus 2 times the y is 5. Let's figure out what that profit's going to be. Again, plug it in your calculator. 4 times 3 minus 2 times 5. That profit's going to be 2. So looking at your 3 profits here, we have a profit of 8, a profit of 20, and a profit of 2. So what would you want to make? $8, $2, or $20? You want to make $20 because profit is making money, right? Your cost is how much you have to pay for a product. Okay, so that means that we would have to use the vertice that it came from, which was 6, 2. So find the minimum. No, sorry, we're still doing maximum. I was thinking that was the final question. So the maximum value is 20 from the point 6, 2. Okay, so that would be the point that we would want to use. So someone would use this at a company to figure out what they would want their selling prices to be in order to maximize that profit. Things like that. I'm not going to make you do any story problems, but I want you to see a good idea of what this is. Okay. Now, cost is how much you have to pay for something to be made. And so you'd figure out that the same way, but what do you want when you have to pay for something? You want to pay for the least amount possible, right? So that's what it means when it says the minimum cost. So again, we still have 3, 2, we still have 6, 2, and we still have 3, 5, and we have to figure out the cost for each of those. So this cost, with the equation to use, is 3 times the x value is 3, plus 2 times the y value is 2. This would give us a cost of, plug it in your calculator, 3 times 3 plus 2 times 2, we get a cost of 13. At the point 6, 2, we're going to plug that one in. 3 times 6 plus 2 times 2, put it in your calculator. 3 times 6 plus 2 times 2, we're at cost of 22. And the last one, 3 times 3 plus 2 times 5, we're at 19. What would you want the cost to be if your options are 13, 22, and 19? 13, because you want to spend the least amount of money as possible when it comes to your cost. Okay, so you tell me that it comes from the 0.32, and our least amount of cost is the 13. So as long as you just circle that, then that will be, tell me which one you know is the minimum. Is that okay? So if you look at your assignment, you guys do have some time to get started on it. Numbers 1 and 2, these ones are already done for you, that they're already graphed. Okay? This one, is this one bounded or unbounded? That one's bounded. What about this one? Is this one bounded or unbounded? This one's unbounded because if you notice, this arrow is going to keep going up and this arrow keeps going to the right. We have no idea how far off this graph we'll ever get to because it keeps going forever and ever and ever. Okay? So from there, you have to first identify what are your vertices. So tell me the points that are your vertices. Okay? Then it says to use those vertices to find the maximum for this one and the minimum for this one. Well, they actually told you the points in your diagram if you were looking. Okay? 3 and 4, so you only have 2 problems today, or 2 like big problems. You actually have to graph. So use your inequalities over here, graph them, then you're going to name the vertices, and then you're going to have to find a minimum. Does that make sense? So just like that example we did on the notes.